All right, here we go. We're going to start our Chapter 6 notes for Algebra 2. So the first thing we always need to do is make sure our learning targets are in our notebook. So I have, at the end of my last section, right, here's where we looked at our inverses of functions, the end of Chapter 5. I left myself kind of a blank page for any questions or any final thoughts about this chapter, so make sure that that happens. And then on your next one, this is where our learning targets are going to go. So today we're going to look through 6.1, and we're really looking at these first 3 learning targets. So I can graph exponential growth and decay. I can use exponential growth and decay to solve problems, and then using compounded interest and finding compounded interest. So the first sheet you're going to need looks like this one. So yes, we are going to actually fold it and kind of glue it in just like this. And I'm going to always make myself a little note at the top of my page. So this I know is 6.1. So we're dealing with exponential growth and decay and what those things look like. Okay, so that's labeled here, so I'm not going to go ahead and do that again. So make sure your papers look kind of like mine. So let's talk about exponential growth really fast. So exponential growth is in this form. This is the kind of equation that we're going to be looking at. So f of x, this is a function, equals ab to the x. You'll see here that my variable, that x, is in the exponent, and that's why it's exponential. So a for here is going to be greater than 0. So a has to be a positive value. And then b has to be also greater than 1. Okay, so that's kind of what we're looking at for exponential growth. Okay, so now our b value, the b thing is called our growth factor. So we're going to write that down, growth factor. Okay, so our growth factor is going to tell us how much is this growing by. That a value that we see here, that's kind of our starting place. What does it really look like? Okay, so now let's look at our growth model. This is really where we're going to be using, what we're going to be using for some of these things. So our growth model is y equals, and then we've got our a value, that's starting, and then 1 plus r to the t. That's really what we're looking at a lot of times. So this r is the rate at which we're growing, and you'll notice here that this is a positive, it's a plus here, and t is generally over time. When we're talking about growth and decay, it's really everything's happening over time, and so we have to kind of use that as our variable. So now let's sketch a quick graph of what exponential growth looks like. So I know that my a value, my kind of y-intercept, is going to be at 1. So here's what it generally looks like. So you'll see that we're just growing very quickly, as we would expect with exponential growth. So an asymptote, let's talk about this. So you see this word asymptote. So an asymptote is a line that our graph or our function approaches but never actually touches. So we see here that our graph approaches the x-axis but never actually touches it. So our asymptote here is the x-axis. So we always want to be cautious about our domain and range, and look at what this really is. So our domain for this is going to be all real numbers, because as you can see, it goes off in both directions forever and ever. Our range here, since we have this asymptote of the x-axis, is going to be that y is greater than 0. So our y will never actually be 0, so here's where we do not have that equal to part on our range. Okay, so now let's look at a little exponential decay. So you'll see here that I have the same equation, the same general equation. So my a is still going to be greater than 0, but the b value is different here. So b is between 0 and 1. So I'm going to go like that. So b in this case is a fraction. Okay, so b in this case, since it's a fraction, it's between 0 and 1, is called our decay factor. So now let's look at our decay model. This is really what we're going to be looking at a lot of times too. So y equals a, 1 minus r to the t. So I want you to take a note of the differences between our growth and decay. We're still looking at a rate, and we're still looking at time. But if we're growing, we're adding, and if we're decaying, we're subtracting that rate. So keep that in mind as well. So now we're going to just graph a quick little sketch. So I know if I'm getting smaller and smaller and smaller, my graph is going to look something like this. You'll see here, and I didn't do a great job drawing it, but I still have an asymptote. My x-axis is still the asymptote. So it's going to approach but never actually touch the x-axis. I want you to think about, for this example, if you cut something in half and you cut it in half again and cut it in half again and again. Can you ever actually get to 0? No, because there's always going to be half of what you had. So that's why we have that asymptote that we never actually touch. Our domain, again, is going to be all real numbers, and our range is still y is greater than 0, because we can't you'll never get to that 0 mark, okay? So here's kind of just our basics of exponential growth and decay and kind of what it looks like and how we can graph them and what it's really looking at, okay? So the next thing we're going to really look at is compound interest. So I'm going to go ahead and take this and glue it in so it's not going to go anywhere, and I know I can refer back to it. And I'm going to leave myself a little bit of space. So sometimes this space is great to be used for some of your homework problems, any questions you come up with, like, oh, that's a great example of this. So on the next page, we're going to be looking at our compound interest. And that looks somewhat like this. So we're going to be gluing across this top piece and using these as little flaps. So if you want to take a second to go ahead and glue and cut it so that we can start filling out the pieces that we need, and we're going to walk through an example of this as well. So I've already got mine cut, so I'm going to go ahead and glue this on my next page. So compound interest. One huge thing that I need you to notice is this word compound, and I'm going to highlight it here. So a lot of students try and use this formula that we're going to go through whenever they see the word interest, and that's not the case. There are several interest formulas. This one can only ever be used if you see that word compound, and we'll explain some of these other things, but you have to have that word compound. That's the key important piece. So here I'm going to use different colors because the colors really actually kind of matter here. So here I have A. That's my first value. So A is my final amount. Okay? So that's what I'm going to say. Underneath this flap, A is my final amount. And when we're dealing with interest, we're dealing with money, right? So you put some money into an account, into a savings or any kind of account that generates this interest. So this A is going to be our final amount that we get. So then my next one is P. And we're going to use a capital P, and that does matter, and that is important. So that capital P is the principal, and that's our starting amount. Okay. Okay, so that's our starting amount. You see here I've got a 1 plus, and then this next blank. This next blank has two things in it. So we are going to have an R divided by N. And then I'm not going to write anything quite under this one quite yet because I still have another N to deal with. And this here is my exponent. Okay, so it really is going to go up there. So underneath both of these flaps, I'm going to flip them both up because N was under both of them. N is the number of times it's compounded per year. So you'll see words like monthly, daily, annually. Annually would mean 1 time per year. Monthly would mean 12 times per year. Okay? So the other variable that we have to deal with in this little section is that R, and that is our rate. The big thing you have to remember with the rate is it has to be in decimal form. It cannot be in percentage form. So you will be given percentage and you'll have to turn it into a decimal. Okay? And then our last little flap, our last piece is T. And that T stands for time, and it's how long has it been in this account. So T is time, and we're talking years when we're dealing with this compound interest. Okay? So now we have this information, and now we can go ahead and use it. So we're actually going to walk through an example together. Okay? So here's our example. So you deposit $9,000 in an account, and I'm going to abbreviate some of my words just so that I can, because I know what I'm talking about, and you can feel free to do that as well as long as you know what your words mean. So in an account that pays 1.46% interest. Okay, so find the balance after 3 years. So if the interest is compounded quarterly. Okay, so let's go ahead and kind of highlight the pieces that we see. So one thing I see is I see that word compound, so that means I can definitely use this equation. So the first thing we're always looking for is that A. That's what I'm being asked to find, is that final balance. Okay, so I'm going to underline that in blue, so that's what I'm trying to find. My principal is at $9,000. That's what I start with. I'm being asked after 3 years is how long I've left this in my account. That N is how many times per year, and that tells me it's quarterly. And then my percent interest is right here, 1.46. So now I can go ahead and just fill in the pieces that I need. So let's go ahead and do that. So I have 9,000. And I'm going to actually definitely use colors here because it's going to really help my mind just kind of understand what we're looking at. So then I have 1 plus my rate, which I turn into a decimal. So when I'm given this percentage and turn it to a decimal, I take the decimal wherever it is and I move it 2 places to the left. So my rate becomes 0.0146. That N value was how many times per year, and quarterly would mean 4 times per year. And so that also comes into play in my exponent. And then I'm asked, okay, so I've had this money in the account for 3 years. What's my total? So now you can see I've got my problem completely laid out. So now you can actually just go ahead and put this in your calculator, and you would find that your final value was approximately $9,402.21. And when we're dealing with this compound interest, we always want to round to the nearest cent, right? Because most people say, how do I round? We're dealing with money here, so we want to round in a way that makes sense. So we're going to definitely round to the nearest cent here. So really now we've walked through looking at compound interest. We've looked at graphing exponential growth and decay. So now you have everything that you need to go ahead and start working on your practice. And as always, make sure you come and find me whenever you get stuck or have questions.